there's anything that you don't understand, okay, let me know. Right, so understand that piezoelectric crystal changes shape when a PD is applied across it, and then the crystal generates EMF when it changes shape. Does that make sense? That's what we saw the other day, right? So they're done. Understand how ultrasound waves are generated and detected by a piezoelectric transducer. How are they generated? What do you do to generate the ultrasound? Apply 2 kilohertz. 2 kilohertz. Yes, we apply a frequency of 20 kilohertz or more. 20 is ultrasound, 2 is not. And it has to be an alternative supply, obviously, right? Right. So how do we make it? Oh, there are frequency generators, devices that do that. So typical supply in your home is how much frequency? 50, 60 hertz, right? Then you can upscale it. So there are devices that create more frequencies and they increase frequencies. They decrease it as well. Remember, capacitors can flatten it out. There are ways to increase it as well. No, transformers will only increase and decrease the voltage. To change frequency, there are other ways out there. There's a device, we don't have it on our syllabus. It's called an inductor. It's basically a coil. That coil can make that change. The coil basically generates or controls the frequency of your AC supply. You can make manipulations using that. Yes? Oh, because I need compressions and rarefactions. So you need it to move in and out. Right, so that and detection too easy. Detection is key. The crystals basically detect the frequency and the amplitude and the wave, and then it generates what because of that? Potential difference voltage, and that voltage is what we read. Okay, so it done. Understand how reflection of pulses of ultrasound at boundaries between tissues can be used for diagnostic information of internal structure. The idea that waves will reflect from where? Different boundaries. What are boundaries? Changes in medium. Okay, so different medium. Define specific acoustic impedance as of a medium as Z equals to rho C. Basically, the definition. It's a product of density and speed, and that is it. So definition ta pray ashe, and students blunder it. Can ওরা just বলে density into speed? No. কি হবে? Yeah, exactly. It's the density of that medium into the product of that with what? The speed of sound in that medium. You have to mention the medium there, okay? Not some random numbers. What is IR by I naught? Mane reflected by incident? Alpha. Very good. This is it. And V would have been appropriate. C is actually the speed of light. Yeah, but C has a special symbolic purposes. C represents speed of anything in a medium. So at the medium, so vacuum. So vacuum যেহেতু particular medium refer করে তার জন্য C use করা হয়। আমাদের আরেকটা জায়গায় C exist করে momentum of a photon equals to hc যেটা ওইটাও same। হ্যাঁ ওইখানে it's the speed of light, you're right। তারপর হচ্ছে আরেকটা আছে P equals to 1/3 rho C square। Right, so a vita এখন দেখবা the more you study V is less prominent, it's actually C more or less সব জায়গায়। Yes, letter. আচ্ছা তারপর হচ্ছে what is this I equals to I naught e to the power minus mu x? Yeah, it's the absorption, how much absorption takes place, where mu is known as the what? Absorption coefficient. It basically is a factor of how much absorption takes place in any medium. Okay, so yeah, there you go. Sorry. Transmitted. Yeah, so once you put I naught and you get an I is what remains. Passes through. Always remember there's a very simple hack here. All the exponential equations, right? We have with this 3 of them. Can you tell me the 3 in our syllabus? Yes, what is it? Q equals to T by RC. Okay, and activity A equals to A naught e to the power minus lambda T, right? And this is I equals to I naught e to the power minus mu x. These are all called exponential decays, right? All these equations will tell you how much remains, not how much decayed. So Q equals to Q naught, it tells you how much charge is left. A equals to A naught, it tells you what activity is remaining. I equals to I naught, it tells you what intensity is remaining. Okay, so if you want to know original, just subtract the I naught from it. Okay, so Aske, we'll start a new device. Yeah. The multi-layer one or the okay. So yeah, just before that, ask আমরা X-rays করব, okay? X-rays হচ্ছে interest in art device. I not this one, right? Yes, okay, sure. So what's happening here? Let's try to understand. So you have this wave coming in here, and then it will go from this boundary, the bone, and come out from the other side. We want to know how much comes out from the other side. Before we do the math, let's try to picture what happens. So you have your wave coming in, and a small fraction of it will what here? Reflect, and the rest will enter. Of the rest that enters, will all of it make its way through, or will it decrease? Decrease because absorbed, right? Of that, a small amount will also what? Reflect because it's a boundary, right? And then what remains is what goes out. So there are how many reflections we need to account for? 2. And how many absorption? 1. So that's the math we did here, okay? So these are the 2 reflections there, and this is the absorption. So how do you do the math? So first, what you do is you find the reflection coefficient here, and the reflection coefficient was 0.376. I'll use percentage, it's easier. So 0.376 is basically 37.6%. That is what reflects. So how much goes through? 100 minus this, right? So 64 point something. We did this, yeah, 62.4% goes through. So if 100 came here, 62.4 enters. Of the 62.4 that enters, will it make all the way through, or will it decrease? Decrease. To find that decrease, we use the absorption equation. So if 62.4% that entered, how much actually makes its way to the other side? Only 35.6%, right? Now, of that 36.5%, how much will get reflected as well? The same factor, right? So we did that, the 35.6% there. So eventually, this is what gets reflected. But wasn't this supposed to move out? Remember that this was supposed to be the one that came out. Of that, if this gets reflected, how much actually makes this way out? Yes, that's what you did here. Okay.
Sure, when it reflects the second time, so you get that boundary again.
And reflect again. And it is it's called, there are 2 words. One is ghost and the other is shadow. So it creates a shadow because there's so many others out there. You'll feel like there are other things around you, but they're not actually. They're basically this just moving around. So it's called a shadow. Shadow happens. And sometimes they call it the ghost image. Like, you have your kidney here, you'll find that there's a like slight shadow image of it next to it. That's because all the reflections out there. Modern day computers can actually remove those, and it only gives you the filtered out version. But yeah, originally it used to be there.
Is that what happened in old pictures?
Old pictures. Oh yeah, the ghost, the pictures that have ghosts in them, they're basically, it's nothing else. Clear? Is there anything else that you need help with? Okay, let's move on. এখন হচ্ছে we'll start X-rays. Again, sorry? Yeah, so you have your crystal here. It's a quartz crystal, piezoelectric crystal. It's now in a stable form, no potential difference across it. You connect this to a AC supply of, let's say, 10 volts. The 10 volts control how much it moves. So if I give 5 volts, it will do that. If I give 10 volts, it will do that. If I give 20, it'll go even further. So the amplitude. So the amplitude is controlled by the voltage. But how often will it do that? It depends on the frequency of the supply. So let's say I'm doing ultrasonography and it's a surface level object. Surface level object meaning that something that's very close to the surface. I don't need too much amplitude. So I'll set my voltage to, let's say, 5 volt, and I'll set my frequency to, let's say, 30,000. And then what will happen is this thing will go up and down 30,000 times every second, and it'll produce a wave of what amplitude? 5. But let's say you want to do like a full abdomen scan, like all the organs in it. Then you want a wave to go very far in. What do you need to provide it? Yeah, so তখন ওরা voltage টা বাড়ায় দেয়, they'll give like 20 volts or something, and maybe high or low frequency depending on how much resolution you want. And then it'll go much further and deeper inside.
And then you put the crystal transducer.
No. Okay, the transducer. The transducer is the crystal. So the crystal is basically the head of the transducer. I'll give you an example of the crystal here. Right there. So there's a glass out there, right? What does it do? It generates infrared. This is a transducer. Not really. It's just a transmitter. There's no receiving here, right? But that thing that's here is like the crystal of a transducer. If it could receive, it would have been the same thing. Okay. X-ray start kori. Any other question? Right. So what are X-rays? And we're like a strange change introduced courses syllabus. I don't know why. It should have been X-rays, then CT scan, then ultrasound. I'll tell you why. In the history of diagnosis, right? The first one was the X-rays. And in the previous syllabus, X-ray course, there were a lot of flaws. We fixed that using what? CT scan. CT scan then had a lot of flaws. We fixed it using what? Ultrasonography. Ultrasonography has flaws. We finally wrapped it up with MRI. They changed the syllabus and it's a little bit all over the place. So we start with ultrasonography, then we do the X-rays, and we wrap up with not MRI anymore. It's called the PET scan. PET scan is super advanced. Like, last 5 years, it became available. It was just one or two labs had it. So the reason why they introduced PET scanning in your syllabus is because it's very hardcore physics. Particle accelerators, radioactive decay, positron emission tomography. It's like proper physics used for it. I don't know, they introduced it. MRI was very basic. MRI or again about this, I don't know. Easy marks. Okay, let's start. X-rays. So how do we generate X-rays? So let's first go back to the origin of X-rays. Just like before, we need to learn how X-rays are generated. Number two, how X-rays are used to create an image. And last, the math. Okay, so let's try to understand the origin of X-rays. Screen it to Dako. So how were X-rays discovered? So the discovery of X-rays is fascinating because it'll help us generate X-rays. So X-ray generation story goes something like that. It's a true story, by the way. There was this person called Roentgen, Rotegen. It's spelling the G is actually not pronounced, Roentgen. So he was working with something called a discharge tube. And discharge tube, I don't know if you have it in chemistry anymore, is basically a tube, right? In which you have electrons flowing through it, and you place a gas inside it. And as the electrons pass through the gas, they excite the gas, and the gas starts to glow. It's called the discharge tube. So এটা হচ্ছে আমরা শিখে আসছি কিছুদিন আগে quantum physics এ remember the tube where if you put a voltage and it glows and it tells you what color it is. Niels Bohr figured out that their energy levels, that's a discharge tube. Very popular in early physics. Everyone was using it because electrons beam করা হচ্ছে, right? So there are electrons flowing through this discharge tube. And এটার ভিতরে যে কোনো গ্যাস দাও, গ্যাসটা glow করে. And gas can glow kore, part of your syllabus. Why does the gas glow if electrons are flowing through it? Yeah, the electrons in the gas get excited to high energy level because they get bombarded with the electrons coming in. They take the energy and go to higher energy level, and when they fall back, they give out the energy out there. So that's why the gas is glowing. Now Roentgen was doing an experiment using a discharge tube, and there was glow and everything going on. But then he found something. He found that, or pashe, there was a piece of paper on the table, right? And on that piece of paper, he momentarily, placed his hand on it or something. And what happened was the paper darkened. And not only the paper darkened, the paper modhe, he saw something. He saw human bones. Bone, right? The only time humans used to see bones before this is when they see what? No, a dead person. Like, you exhume like a dead body or something and you find remains talking bone randomly on a paper a bone this is a bit of an odd thing. So what he did was, Roentgen, he thought that it's a bad omen. It's basically a vision of his death coming by. So he literally stopped doing the experiment and he just went into seclusion, waiting for his death. That's it. Like a paper the bones, right? But then he eventually realized, I think his wife encouraged him to go out of the house and start working again. And then he went out and he started doing the experiment again. And this time what he did was, he tried to figure out, Jay, what's happening. He's a person of science, right? I mean, momentarily he went backwards, but he is a person of science, right? And eventually he realized that to recreate this, right, you needed some special setup. And he started scouring the lab. Like that day, what actually happened that caused this to show up, right? And he saw there's a discharge tube, tao hocche na, voltage change korse, tao hocche na, paper change korse, tao hocche na. And then he realized that when he was doing the experiment, unknowingly, right next to that particular discharge tube, there was a very big block of lead. So there's a piece of lead just lying around for other purpose. Like he was doing some other experiment. And it's a very strange coincidence that when very high energy electrons, listen to this carefully, okay, this is how X-rays are generated. When very high energy electrons go and collide with lead, nothing else, okay, no other element, lead, what happens is the lead surface takes in all the energy. যা energy আসতেছে from the electron, সব নিয়ে নেয়, 99.9%. But with lead, there's this very interesting outcome. 0.1% of the energy taken in is given out by lead, not really lead, the electrons, in the form of this mysterious wave back in the day. And this mysterious wave was part of the electromagnetic spectrum, and they're known as what? X-rays. So he figured out that there are these waves coming out, and he called them X-rays because unknown X, right? And he figured out that this only works under a very strict condition. By the way, conditioning is applicable. You need very fast moving electrons, highly energetic electrons, and you need a metal that's extremely what? Dense. Often we use tungsten, osmium, other things to keep our devices light, but very dense metal. And whenever a dense metal tries to stop electrons, right, at the phenomena generated by called the break-in radiation, break kora mane stop kora. So we now understand, and it's very basic physics actually, if you think about it, an electron is moving very fast. And the electron has a lot of energy in it, right? And as the electron approaches the very dense metal, there are a lot of electrons in that very dense metal. What are they doing to your electron? Slowing them down, repelling. Very good. Your electron slows down. The electron loses energy. It loses what energy? The kinetic energy. The question mark was, where did the energy go? When energy যেতে হবে তো, right? We didn't really understand. যে slow হয়ে যাচ্ছে, where is the energy dissipated? Later on, we found that if the electron enters the field, it's doing work against the field, and that energy is dissipated within the material as internal energy. But for lead, the break-in is so rapid, it can't even enter the surface before which it stops. If such things happen, the energy is translated instantly into radiation coming out from the object. And the radiation that exclusively comes out from this kind of break-in radiation is X-rays. Almost 80 years later, we found this again in a new place at the event horizon of a black hole. So event horizon of a black hole is basically a black hole boundary. Particles are moving very fast, right? At the point that they can't keep the energy in, they start to give off the energy in the form of what? X-rays again. And Hawking radiation arc does, where black holes start to give off their own energy, right? All comes from this particular interaction, that when a mass can't store energy anymore, what does it do to the energy? Release it in the form of what only? X-rays. Okay, so not like gamma rays or ultraviolet, it just produces X-rays. So this is called break-in radiation. I'll show you more diagrams about it, but the thing is, details with math and graph. All you need to know now is that to make X-rays, you need to take fast-moving electrons and what them? Stop them. And as you stop them, they have to lose their energy. They lose their energy in the form of what? X-rays. Okay, if you think about the process, it's highly inefficient. Why? Of the total energy you're generating, 99.9% is actually lost in the metal in the form of what? Heat. Only 0.1% is actually given off in the form of what? X-rays. So আমাদের যে ডিজাইনটা করতে হবে, এখন আমরা ডিজাইন করব একটা X-ray machine, ওইখানে we need to take that into account. How can we make it more efficient? You get my point? So this is the origin stories of X-ray. এটা not যে আমাদের জানতে হবে, এটা just তোমাদেরকে একটা context দিলাম that how did they discover this. So discovery is completely accidental. And if there's anything purely accidental, this is an example of it. Yeah. Kunta? There. Yes. Sorry? The break-in radiation formula, there's a formula. A formula mode, if you take the kinetic energy, very high value, right, and you place it in that equation, the wavelength that we get falls in the range of this. So the deceleration that takes place leads to X-ray production. The same way how electron transition in metals will only produce visible light. Similarly, this produces X-rays only. Okay, so yeah, this is him, and that's the hand. And that's the first X-ray. Yeah, the পরে হচ্ছে he made his wife actually do an X-ray. So that's the first official X-ray that you have. Okay, so yeah, that's how it was generated. This is actually the image. That's how they know it's theirs. Otherwise, they'll have some ghost. Whose hand is that? It's everyone's hand has bones in it, right? So yeah, it's exactly the ring that she had. So yeah, that's how X-rays are generated. This is where he was doing the experiment. ওই discharge tube-টা সামনে, এই পিছনে there was a block of lead. It was basically a container for storing radioactive material. Remember, you stored them in lead container. ওই container was responsible for it. Later on, obviously, fixed it, but that's how X-rays are generated. So let's now make an industrial level X-ray machine. মানে যেটা তোমরা actually hospital-এ গিয়ে দেখো. So what are the parts to it? So let's start. So the first হচ্ছে, we need to find a mechanism to generate what? X-rays, right? So how do we generate X-rays, or sorry, electrons? Can you give me a way to generate electrons we have seen before? Huh? No. এটা পারা উচিত তো। No. আচ্ছা, but মনে হচ্ছে এটা ছিল সেম টপিক তো আছে, I don't know তোমাদের কি করাইছে নাকি না. Remember the electron diffraction, the place where you have like a salt crystal and the electron passes through it and it diffracts, right? So how are electrons generated there? Slits? No. I'm দেখে ছবি দেখে। Right. So I'm going to explain quickly. Do you see this device here that produces the electrons, right? That's called the electron gun. And a electron like they bear, and as these electrons pass through your chamber here, কি করে? They diffract, right? Now, a electron gun এর মতন হচ্ছে আরেকটা করে সময়টা পরে দেখাচ্ছি. Remember the velocity selector? There was a target. Acha, back for now, I'll just go through it one more time. So how do you produce electrons? Like, you want electrons and you want electrons of exactly the speed that you want. So এটা আমাদের হচ্ছে combined একটা question আসতে পারে. So the way you do this is you take a metal filament. একটা filament মানে হচ্ছে একটা piece of metal, and you provide a watt across it, a very high potential. The potential that you provide here is supposed to be something in the range of 5,000, 6,000, 10,000 volts. Okay, so 5 kilovolts at the voltage provide korba. What happens as a consequence of that is this metal filament will start to what in the process? Heat up. And as it starts to heat up, at one point it becomes too hot, and the electrons in this metal will start to escape. And there's a name for this process. It's called thermionic emission. Thermionic emission. You guys went close. You used photoelectric emission. The electrons bear because of light. Electrons bear but not because of light, because of what? Heat. It's called thermionic emission. Thermionic emission is basically you take a metal, you heat it up a lot. At one point, it heats up so much that the electrons start to leave it because they have enough energy to escape. So that's the filament. এটাকে বলা হয় filament. This is the first part of our X-ray machine. So you need to have a filament. Now this whole No, the reason behind it is in photoelectric emission, you have to use a light source. The light will travel a distance and fall on your surface, and then it'll emit, right? So you have a lot of efficiency issues. When light is coming out from your source, right, which way does it go? Everywhere, right? But your filament is like a small part there. It's not capturing all the light out there. Having a filament like this means every voltage, every charge, every energy goes to the filament only. So it's more efficient. I mean, you could have done that as well, but this is more efficient. No, it's not really a problem, because electrons will first use the energy. If nothing is left, that's when dissipation takes place. Now, what we do is we take this whole chamber and আমরা একটা কেসিনের মধ্যে রাখি। এই কেসিনটা ডটেড লাইন দিয়ে দিচ্ছি বিকজ এটা হচ্ছে নট ভেরি ইম্পর্টেন্ট, বাট জানতে হবে everything inside this is a vacuum. You can't have anything else here because the electrons, as they're flowing, if there is air involved, they'll slow down. They'll not have the energy, right? Now the problem কি, এখান থেকে ইলেকট্রন বের হবে, ইলেকট্রন গুলো সব ডিফারেন্ট ভেলোসিটিতে বের হবে। কেউ আমাকে একটু রিমাইন্ডার দিতে পারবা why would they have different velocities? Very good. Remember that photoelectric effect, the electrons did not have the same energy because they came from different places. এখানেও same জিনিস হচ্ছে। So the electrons that are coming out, they are not actually the same speed. But having same speed is very important for us. So আমরা যেটা করি, এখানে আরেকটা ছোট গ্যাপ রাখি আর একটা প্লেট কানেক্ট করি to a positive terminal of a power supply. And this one is called the accelerating anode. Accelerating anode হচ্ছে a place where the electrons will speed up and rush through because they're being accelerated. It's like imagine objects are going straight, they're falling, right? And and what you do is you have an open gate here. Wouldn't they just pass through the gate? So these electrons out there at that they're trying to go and collide with what the positive terminals there, right? But they're so fast that before they can actually turn sideways, what do? They make their way out. This is only possible if you make them accelerate to what speeds? Extremely high speeds. কারণ যদি স্লো হয় তাহলে কি হবে, যে এরকম হয়ে উপরে চলে যাবে, নিচে চলে যাবে। Anode, by the way, is what charge? Positive. And electrons are what charge? Negative, right? But if they're very fast, they're trying to bend, but before they can bend, where are they? They've crossed it. And once they cross this thing, এখানে আমরা আরেকটা anode রাখি just to make sure that the electrons end up here. This one is made up of the dense metal that we have. So এটা dense metal যেটা, এটা ওইটার সাথে connected. So can you tell me what is positively charged in this setup? The anode and this metal out there. So these are positively charged. Do you follow? So এগুলা positive charge থাকে, and sorry to fix for any. And this positively charged metal is lead here. Or a lead use করে, or you can use tungsten. Basically, what density? High density. Okay. Currently, what I've heard is they use like an alloy, artificially made. The more the density, the better the breaking. That, you know, they have made like an alloy that's combination of all the properties out there. They don't heat up and whatnot. Anyways, your electrons are moving through this. The electrons are going at very high velocity, stream of electrons. And these electrons are extremely fast. We take them to speed of the 10% speed of light. And then the electrons suddenly face what? Lead. So let me show you what happens in lead. So these are your positive ions of lead. Lead is one of the most dense metals out there, only beaten by what? Tungsten and osmium. Osmium is the most dense, okay? So these are your lead atoms out there, very, very densely packed. Also, leader proton number is very high, which means what is very high? The electron number. So there are a lot of water around it as well, electrons. A lot of electrons will also mean that the what is very large and big in size. Yeah, the delocalized electrons are a lot, right? And the repulsion is very lot. So this is how your lead looks like. Now, what happens is, look at this carefully. You have these electrons coming in, right? And they're moving at extremely high speeds. Now, as they start to approach, what are they experiencing from the lead? Repulsion. And because of repulsion, what do they start to do? They slow down. Majority of them, as I told you, like, 99% of them will actually come and collide here. As they come and collide here, the energy that they have is given to the lead ions here. And what do the lead ions do here? They start to heat up, right? The lead ions start to heat up here, the temperature rises and everything. Do you follow? But some electrons slow down so much before they reach here. In a very strange random occurrence, they start to give off the energy they have in the form of what? X-rays. Eta was the mystery back then. We didn't know. Now we understand there's something called the break-in radiation, but that's where X-rays come from. So if you want to generate X-rays, you have to do this. You have to slow your electrons down so much that they face so much repulsion. All their energy is gone before they even reach the target. That means the energy has to be given off in the form of what? Something that's waveform. And what's waveform? Electromagnetic radiation. And the energy is so much that if you do E equals to HF, remember, the E that's given off gives the what frequency? X-ray range frequency, okay? So what happens now is that 99% of the energy is taken in here in the form of what energy? Internal energy. When the particles are gaining energy, and only 1% of it is given off what? X-rays. X-ray গুলো কোথায় যাবে? So the X-rays are supposed to, in theory, go back. মানে এদিক দিয়ে চলে যাচ্ছে, বাট আমাকে তো X-ray কোনো এক জায়গায় টার্গেট করতে হবে। সো এখানে যেটা করা হয়, একটা স্পেশাল অ্যাঙ্গেলে জিনিসটা রাখা হয়, so that when the X-rays come out from here, where do they go? Down. And these X-rays are then directed down like that through this very small opening out there. It's called an aperture. You know what an aperture is? Camera open the aperture bola hoy. Tomদের syllabus, I think they changed the name. Now they call it the window. So এখানে window থাকে. It's actually a glass window. Is you want your X-rays not to feel any hindrance, right? So এটা ভিতর দিয়ে X-ray টা বের হয়. It's a very small part in the X-ray machine. X-ray machine usually a উপরে বক্সটার মতন size হয়, and the place where the X-ray comes out from is like something like that. এরকম একটা size. Yeah, it's very small. How far your object is, like the X-ray machine এবার উঁচু নিচু left right করতে পারে, how far it is gives you more range and more coverage. So if I want to do an X-ray of something very close, like let's say the hand, they'll bring it down there. If they want to do an X-ray of your, let's say, full chest, right, they'll take it up there. And as you know, the further you take, the greater the dissipation, right? So there's nothing you can do here. You can only control the coverage by moving it which way, up and down. Okay, there are other things we'll be learning. So manage, but that's how X-rays are generated. Now inside this chamber, you have vacuum, as I mentioned earlier. This is the window, and this thing heats up a lot. It heat up that in some cases, right, it turns red and glows, which is not a good thing to have in a hospital because it's a fire hazard, right? So alright, fix they came up with many different solutions. Currently, the solution to use for high-end is that this thing has a liquid running over it. It's a liquid-based coolant. Processors use water cooler use there's like water continuously going over your device. It can act a liquid run. What does the liquid continuously take away from your radiator, right? On top of that, this spins. If you next time do an X-ray, if the machine is very old, right, you can hear a sound. It's basically this thing is rotating. What's the advantage of rotating this? Very good. So to me, that one place will overheat. By keeping it rotating all the time, it's basically getting heated everywhere. So you're allowing the other parts to cool down meanwhile. So it's not one place all the time. Okay. So it rotates, and also there's a cooling system out there. All together, that's the X-ray machine. Oh, the filament is fine. It doesn't heat up. It can take a lot of heat, 5,000, 6,000 degrees Celsius, and that's producing the electrons. Yes. We'll learn exactly what it does to your cells. So আমাদের হচ্ছে এখানে শিখতে হবে যে X-ray advantage কি, but disadvantage গুলো আরো বেশি। So ওগুলো দেখতে হবে। Sorry. The electrons. So they slow down, they stop, and then they go back. But because they stopped, right, the energy had to go somewhere. What was that? X-ray. But those electrons will go back, or they'll get absorbed by the filament. Also, you have this positive terminal here, right? Eventually, they can go the other way as well. But generally, they're so fast, right, that they have only one way going forwards, and then suddenly they're brought to a stop. This is like a very intense stopping process, breaking kora hocche. That produces the X-rays. If you gradually slow them down, it doesn't produce X-rays. It has to happen at a very fast rate. So it'll probably have entered the metal by then, and the energy goes as internal energy. And that's what happens when you typically fire electrons at any material. It just warms up. Okay, let's see some demonstrations out there. তোমাদের কোনো question আছে the structure of your X-ray machine নিয়ে? থাকলে আমাকে বলতে পারো। Which is the cooling process, the preventing overheating, using a filament by using positive cathode to anode to accelerate them. These all features, the vacuum, they all collectively make it more effective. Yeah, no matter what you do, it can't be more than 1%. The break-in radiation, the number of electrons intensity will increase, but not the percentage. So you wanted to increase the speed of electrons, intensity increases. It'll be less likely to produce X-rays because they'll be slowing down over a larger area. That'll be better. So this actually happens in a very small place. I mean, my diagram looks very big, but the whole contraption is like that small. So within that, everything happens. But you'll find that the X-ray thing is very big. The majority of the mechanism that you see there is actually for it to be cooled down, nothing else, because it heats up a lot. Right, so this is the answer. I'll just go through the answer very quickly. So how are X-rays generated, okay? There are different types of questions you get. Shagulo compile code, I made one here. When fast-moving electrons approach dense metals such as lead, the electrons experience repulsion from the metallic delocalized electrons and undergo a what important? What deceleration? Rapid. This deceleration will happen with any metal, right? Because there are positive ions and delocalized electrons, but we need rapid deceleration. This deceleration leads to kinetic energy loss, which is emitted as X-rays. Only around 1% of the energy is released as X-rays, and the rest is absorbed by lead upon impact with the electrons. This is why lead heats up during the bombardment with the electrons. So that's the heating process. And what are the parts of your X-ray machine? This is another question you get. Filament connected to a high voltage supply. The filament connected to a high voltage supply releases electrons through, what's the name of the process? Thermionic emission. Or one market, what's a thermionic emission? It's the emission of electrons due to provision of what? High potential difference or high temperature, okay? High potential difference or high temperature. Provision, like to provide, by providing either high potential difference or high temperature. This is the emission that takes place when a high temperature filament emits electrons. Why lead is needed? Lead is there to stop or slow down the electrons that have accelerated due to the positive terminal of the power supply. These electrons slowing down releases X-rays in a process known as the what radiation? The break-in radiation. Break, not bhanga. The metal is connected by rotating system to allow the electrons to collide at different parts at all time. This is done to ensure that no single section overheats. We rotate with it again. Our vacuum chamber can use the electrons are accelerated in a vacuum chamber to ensure they do not get obstructed or slow down by air particles. Okay, this is basically the structure of your X-ray machine. Bolo amake questions. Yeah. When they're repelled, they slow down, but they end up in the metal eventually. Because they have enough energy to reach the metal, but they will become very slow before they reach the metal. So while they're slowing down, aren't they losing energy? That is lost in the form of X-rays. And if they collide with the material, then the energy is lost as impact, internal energy, the particles gain kinetic energy. and they'll end up there. The reason why they end up there, and we make sure they end up there, is because we did something here. We connected our metal to what? A positive electrode, right? So they will end up there eventually. If you don't make this positive, there's a chance that they'll start to slow down, because isn't this positive as well? So they'll start to feel a bit of attraction from that side. So you have to make sure they go the other way. Insulate the, like here, behind it. Insulate it, like with a thermal insulator. Charged insulator. Oh, what will that do? Prevent attraction of electrons. No, like attraction from which side? This side. Oh, yes, I understand. You're telling me to insulate this part, right? Yeah, they have things that they do there. But the thing was that the hard question was that what if the electrons like slow down entirely and they're like completely lost their energy here? What if the X-rays are released further out? It could be possible, right? We want the X-ray to be released where? Just before it hits the metal. So we want to make sure that the electrons do reach the metal. And we can only do that by ensuring that this is what charge? Positive. Right, so the answer is here. আজকে আমি আরেকটা জিনিস পড়াবো because I want to wrap up X-rays by next class. এটা খুব ইন্টারেস্টিং যেটা এখন পড়াবো ওটা হচ্ছে how do X-rays produce an image? We get it. It's a mysterious wave and accidentally বের করছে এরকম তো অনেক কিছু বের হয়, right? But why are X-rays capable of showing your bones and not anything else, right? Right. And yeah, I mean that's actually true. So since you guys have some idea, আমাকে একটু বলবা কি হয়? So tell me why if you put like a hand on a X-ray কিছু উপরে রাখে? Very good, right? And what's that thing? Scanner? The scan. The film. Oh, like they put a film there, or like okay. No, surprisingly, ভালো. I really hope that the X-ray আসে তোমাদের exam because অনেক কিছুই বলছো ঠিকঠাক. আমি বলি কি হচ্ছে এখানে? So পুরো জিনিসটা দেখাই. So we have the window here, right? And এই উইন্ডোতে কি বের হচ্ছে? Your X-rays. So একটু স্ক্রিনে দেখো, let me explain the whole thing. তোমাদের যদি কোনো understanding gap থাকে তাহলে hopefully I'll cover that out. Initially, the X-ray is what intensity? Very strong. But as the X-ray starts to travel, right? What does it start to become? Weak. And এটা তোমাদেরকে explain করতে হবে কেন হয়? কেউ কি আমাকে explain করতে পারবা why is the X-ray becoming weak as it travels a certain distance? Huh? No. X-ray তো air particles এর সাথে collide করবে না. X-ray তো wave. Yes. What's the formula? Yes, intensity equals to P divided by 4 pi d square. A is intensity equation over distance, right? So that, or intensity is power divided by area over which it dissipates. Oda to hocche generic equation, but wasn't there an inverse square law that every time you go a distance of x, the intensity decreases by a square factor? So that's the reason why it dies out very soon. Is it a good thing or a bad thing? Huh? So here's a question for you, okay? The X-ray that reaches my body is low intensity. Is that good or bad? It's horrible. It is the worst thing that can happen. I'll tell you why. If it's very low intensity, it means your body will then take the rest of it. And if your body takes the rest of it, your body has cells that will take rest of it and it will cause mutation. We want to make sure that the X-rays that are not needed, right? Where do they go? Through our body, so that it doesn't do anything to our body. If they stop in our body, it means the energy went to our body, and energy in the body will cause cells to change their structure and undergo ionization and mutation, right? So we want to make sure the intensity is high. Low intensity is actually bad. High intensity is good. And then you may wonder, tell the bones, what about that? Bones are rocks. But literally, they're rocks. They're nothing else. They're mineralized rocks in your body. That's what bones are. Mutation the only thing that can mutate in your bone is your bone marrow. And bone marrow is inside the bone before X-rays can actually reach that place. So that's why bones are X-ray, there's no problem with that. Do you get my point? Okay, let's move on. So let's say I want to do the X-ray of a person's arm. So yeah, this is the arm here, and তোমার হচ্ছে মাঝখানে হচ্ছে you have the bone. So you want to do an X-ray of the arm. Now, how does this show up on the X-ray machine? কেমনে হচ্ছে ইমেজটা ফর্ম হয়? So তোমরা যেটা বলছো, it's not bad, but there are way more things going on here. So first of all, you have to place the arm on something called a lead collimator. And we have done this before. Do you remember lead collimator? কোথায়? Yes, very good. Lead collimator is basically আমাকে বলো তো দেখি পারো নাকি তোমরা, কি ছিল এটা? Yeah, it was a lead metal that had lots of water in it, small gaps in it, and the gaps were used. এটা ইউজ করা হতো আমাদের হচ্ছে ওই রাদারফোর্ড স্ক্যাটারিং, আলফা স্ক্যাটারিং এক্সপেরিমেন্ট, ওইসব জায়গায় ইউজ করা হতো। lead collimator ইউজ করা হয়। কেন ইউজ করা হয়? I'll show you in a minute. Exactly. You know what the problem is with X-rays? যদি এটা না ইউজ করো, X-ray এদিক দিয়ে যাচ্ছে, এদিক দিয়ে যাচ্ছে, এদিক দিয়ে যাচ্ছে, they're going everywhere because they're coming from different angles. So তখন যেটা হবে, the X-ray at the bottom will be from different places. It'll create a very poor image. It's a shadowy image. I want the X-rays to only fall that are what on the page? Perpendicular. তাহলে কি ওই লোকেশনটাই শো করতেছে না? এটা ইউজ করে, it's a filter. এটার নিচে হচ্ছে we place the X-ray film যেটা তোমরা বলছো, এটা is made up of silver nitrate এর একটা compound, and you know that in chemistry silver is photo sensitive একটা chemical. Do you know that silver if kept under light changes color? আচ্ছা, যদি না জানো প্রবলেম নাই। Do you remember the old film cameras? ওটার ভিতরে একটা ফিল্ম থাকতো, ওইটার এটা সেম। It's basically a chemical যেটার উপরে কোনো এনার্জি যদি আসে in any form, it darkens itself. And the higher the energy, the more darker it gets. So যখন আগে ক্যামেরাতে ছবি তুলতো, the light would reflect and come back. Different lights would have different intensities, and they'll cause like a negative to form. Then they would process that to produce what? The image, right? So এখানে ফিল্মটা থাকে। ফিল্মটা originally is transparent, or like almost transparent, is translucent, কোনো কিছু থাকে না। Let's say you put your arm over it, তাহলে কি show করবে? So if you put your arm over it, তোমার armএর ভিতরে you have bones, muscles, tissues, veins, a lot of things going on, right? So let's say these are your bones and joints, okay? So at a simple image, okay. Now once you pass X-ray through it, right, এই যে পাশের যে side গুলো, these there are, right? So এই যে সাইডের যে জায়গাগুলো, these are made up of what? Muscles and tissues. Can you give me the chemical composition of it? Last class এ বলছিলা muscles and tissues are chemical composition, protein composition. CHONPS, carbon, hydrogen, oxygen, nitrogen, sulfur, phosphorus, right? Are they very dense? No, they're not very dense, okay? So এটা থাকবে। Now can you give me a composition of fat? Yeah, fat is pure carbohydrates. It's very few other heavy elements out there, right? So what happens is when you do an X-ray, there are different elements out there. X-ray cast out carefully. This is very important. The higher the density of the material, the more they want the X-ray absorb it. So once you beam X-rays down here, what is the outcome that we get? So if you look at the page here, you'll find that this page completely darkens. Can you completely darken হয়ে যাবে? Because X-ray to পাশে জায়গাগুলোতে nothing is stopping it. It just goes straight through. But the place where your arm is, right, একটু একটা shadowy image দিবে। কেন shadowy image দিবে? Because it contains muscles and tissues which are obviously more dense than air. So there'll be a slight ghostly image like that. And মাঝখানে, the place where your bone is, completely what the X-rays blocks it. And as a consequence, you'll find that that is the most clearly visible one out there. Once in a while, you may see things like that. What are those? Your veins, which carry what? Blood, and that carries what? Oxygen, carrying either iron, hemoglobin. Hemoglobin is iron, which is like high density, so it can block it somewhat as well. And that's the X-ray that you see. So the rest of your body is actually just letting the X-ray pass through. Best হয়তো যদি খালি বোনটা দেখা যেত আর পাশে কিছু দেখা যেত না, which means your body did not what? Absorb anything at all, like the tissues and muscles. That's the safer version, okay? But কিছু একটু দেখা যায়, which means that either the technician's setting was little off, or the distance that was not correct. A proper X-ray of your bone, right, will only show your what? Bone. বাকিগুলো দেখানোর কথা না, because বাকিগুলো তো হচ্ছে তোমার দরকার নাই। But ওরা যদি show up করে, it means they were absorbing X-rays, which is risky. So you shouldn't do, and I think I said this the other day, more than 2 X-rays every 6 months, okay? Because the number is that every time you do an X-ray within 6 months, it triples the chance of getting cancer. Triples, 300%. Okay, so yeah, don't do it. You can do MRI 100 times a day, problem nahi. It puts a magnetic field around your body, and it magnetizes the water inside your body, the electrons. Nothing happens. You wouldn't even know. MRI can see nerves and ligaments. X-rays can't see it. Takes 10 seconds. The MRI takes 1 hour. They put you in a machine. And sorry? There are no questions from 2020. Oh, hey. So এটা হচ্ছিল 20 থেকে 20 2 পর্যন্ত থাকার কথা 22 থাকার কথা তো এই যে
First chapter এটা না, first chapter।
ও ফার্স্ট চ্যাপ্টারে ছিল না কোনো কোশ্চেন্স মানে আর তোমার হচ্ছে যে সার্কুলার মোশন যেটা এই যে এখানে 22 আছে হ্যাঁ সো 23 and 24 আমরা ক্লাসে করবো as full papers
আমি just জানতে চাচ্ছি that currently আমি তো পাস পেপার শুরু করলে কি appropriate
করা উচিত ছিল না the book has given right if you start with that right now it's the best time to start so these are past papers so the whole past paper no you can simultaneously do it so you can simultaneously do it right now as well the aim of doing this is because when you're solving a past paper right you're getting a hint of all the questions out there but let's say you have a chapter that you have trouble with so wouldn't it be better to just focus on that because in one past paper you get only one problem from that one chapter you can do this right and do past paper my suggestion is do past papers and as you do past papers you'll find that there are certain questions that you don't get those chapters do these questions from those chapters okay this is for refinement
Oh, thank you.